and thank you for attending today's webinar, How Open RAN Technologies Will Change Mobile Networks in the Future, sponsored by Red Hat. I would now like to turn the event over to Daryl Schooler, OMDIA's Practice Leader, Service Provider Networks. Daryl?
Thank you. And thanks everybody for joining us today. I think this is definitely going to be an interesting discussion on Open RAN, and I'm really excited to be a part of this and hear from different people within the overall ecosystem who have different perspectives as they come to this from different areas within the network. The speakers we have today will be Ravi from Altiostar, Michael from Red Hat, followed by Sunil from IBM. And this is the agenda here, and at the end, conclusions and also where to reach us for any questions. But first, let me spend a few minutes just kind of giving an overview of the topic and highlight some of the commercial activity that is going on today. So first, when talking about this topic, I often like to first dig into the words and what they mean. Because as an analyst, it's always important when you're trying to measure a market, quantify something, to make sure that the methodology one is using is clear, and also that as you look at the market and compare it to other markets and such, that you are really doing a proper apples-to-apples comparison. So when it comes to Open RAN, there's a lot of terms out there, and I see them used different way, but these are a couple of the terms that you hear a lot, and specifically more what they mean, such as O-RAN at the top. O-RAN is really the Open RAN Alliance, which is a mobile industry alliance of operators and vendors who are helping to define and create specifications for different interfaces within the RAN, with the general idea that you can take what is basically a kind of a closed system now, and by opening those interfaces, be able to swap out different parts of the network. Particularly the one a lot of people talk about is mixing radio vendors with a different DU, CU, or baseband vendor. Then there's also TIP Open RAN. As you see, Open RAN is one word as they presented. This group is really about creating use cases and driving commercial adoption of Open RAN networks and solutions. And then there's just the more Open RAN, which in my mind is really something of a generic term. And I say that because if you look at some Open RAN deployments, some of them may have all O-RAN specifications. Some may have some proprietary type solutions to create open interfaces as well. And also with Open RAN, though, while we start talking about front haul often, we are going to eventually, due to the work at O-RAN and such, get into other interfaces. One in particular that a lot of people are talking about these days is the radio intelligent controller. And then there's vRAN or virtualized RAN, which sometimes people refer to as Cloud RAN or C-RAN or centralized RAN. This is really about the virtualization of the base station in terms of separating the software from the hardware and putting it more on the software on commercial off-the-shelf type servers. So I would say when people ask me, all virtualized networks or cloud networks are not open, and you certainly can have an open network that is not virtualized, but it's really the convergence of two that most people are talking about, because in my opinion, it really, in many cases, brings out the best of both and really opens up the commercial and the service opportunities the greatest for the mobile operator. So generally when you hear talk about Open RAN, they are basically talking or generally talking about both open and virtual convergence. So in terms of some of the drivers, and many of these you probably have heard before, talking about increased vendor choice, which also leads to maintaining competitiveness, vendor security in terms of, if you have to swap out a vendor, you may not have to remove the entire RAN, but with open interfaces, you may just be able to do part of it. And then best of breed features, bringing new features to the market, the whole idea that as everything becomes software and virtualized, The operator is no longer, say, tied to just the capabilities of the hardware or stuck with, say, a hardware vendor and that vendor's software update cycles, that they can really do things faster and have the ability to pick and choose whichever parts of the network and whichever features they want the most. And other things we've also seen that in some ways is part of an overall cultural shift with some operators trying to move to a more cloud-like environment, and the RAN is part of that, and that they're looking to move on there. And last but not least, of course, is always the issue of lower CapEx, which is, of course, can be part of choice. It can also be part of, say, trying to find more economical ways to reach people in, say, low-density markets. Certainly, this is always an important issue for operators, but I also would say at the same time from my own research, it is not the only operator or the only driver. It is oftentimes put into context with the other drivers as well. But to be honest, I mean, this is also still somewhat of a new type of network architecture, and the interfaces involved are somewhat new. So in terms of when I talk to operators again about, what are the challenges with this, some cases they talk about the solution maturity, whether it's the interfaces or, say, the server performance or the radio performance there, which, they also want, that they want feature parity, say, between a traditional purpose-built system and an open system, which other issues, of course, though, as you expand the number of vendors, certainly there's a concern about, system integration, adding more complexity. Especially you hear this a lot more, say, from some smaller operators that may not have the same kinds of resources as some of the larger tier 1 global operators do. And then, of course, at the same time, there are certainly corporate culture issues that cannot be overlooked. The people there, they need to embrace cloud culture. It can be a very different way of how they're working. So there is a cultural shift that needs to be overcome as part of this as well. Another thing I also talk about Open RAN, when you think about Open RAN, you shouldn't think of it as one singular thing. So I put these different types of radios up here, and I am not saying that these are all open. Certainly some of them I can look at right here, and I'm pretty sure that the vendor hasn't made them open yet. But they do symbolize the different types of deployments out there, where it's rural, massive MIMO, small cells outdoor, indoor small cells, mid-band radios, as well as we start to move into 5G, the 3.5 band, or even millimeter wave band. Open RAN is somewhat the same as when you think about it. All solutions are not the same. They can be used to address various different scenarios, deployments, geographies, venues, services, all of those things. So from an operator perspective, I think they should be looking at Open RAN, or they think about Open RAN, looking at the different ways that they deploy their networks, the different network needs, and looking at it in that regard. Whether they want to embrace Open RAN as a full-scale macro network, or as, say, an additive or an enhancement to an existing macro network. Those are all options that can be explored with Open RAN. So in terms of commercial activities, honestly, this is still still a new new architecture, somewhat of a new approach to building your network. But I think from, if I was an operator, what would, give me some comfort or be enthused about it is the fact that there is definitely global momentum behind it. So this comes from the people at the Telecom Infrastructure Project. And to be honest with you, this market is moving so quick. Even though I just recently got this diagram, it is still not 100% up to date because it keeps changing. But the takeaway from this is that Open RAN is not just one market or one operator. It is really global. And the other takeaway, I think, from this is the fact that this is a change that is really being driven by the operator community, not something being pushed on them by the vendor community, which, again, is very good when you look at this market, because I've certainly been around long enough to see things pushed by vendors that go nowhere because operators don't have much interest in it. So now I'm just going to take a few minutes, just walk you through some of the different higher profile type deployments out there to give you an idea of some of the things going on. So first, you get the greenfield networks, which get a lot of attention. because they're large scale volume. The press certainly, and analysts like myself certainly spend a lot of attention on them, because in many cases right now they are probably some of the best examples of what's going out there. I mean, so Rakuten, of course, is the one that everybody hears the most about, and they're really in the process of building a large scale 4G, 5G network. And they've talked about how, with their solution that they're looking to say like 40% in CapEx and 30% in OpEx versus what they believe it would have cost them to have built the network using more traditional type solutions. Then you have Dish Network, which is in my home country here of the United States. They'll start building this year. They are also building a greenfield network that is going to be a very large volume site type network that they're going to be building out over the next several years. Both of these are certainly high profile proof points of this technology or this market Open RAN. But of course, also I would say, though, they're also something unique because they're greenfield. So they deal with a different set of problems than say, a brownfield network. An operator that already has a network and is looking to add Open RAN to it, which are going to move at definitely a different pace. But at the same time, brownfield are, probably, they make it the majority of operators and the majority of the opportunity within this. So two of the high-profile ones that I focus on are these European multinationals, Telefonica and Vodafone. They've done a lot of work in terms of work with TIP, working with the specifications, really also, putting their own capital behind the deployments in terms of trying to build up the ecosystem and setting some very ambitious goals when it comes to rolling out networks. Like for overall, Vodafone keeps, talking about, by the end of 2024, having 100,000 sites globally supporting Open RAN. And they do have several networks going on right now. They're looking to even build like 4,000 sites in the UK. I know they have another one, I think, around in that same size in Africa as well. And then, there's Telefonica, which is talking about by the end of 2025 that their goal is by that year, 50% of all new sites that they deploy will be supporting Open RAN. And then, within the Asia Pacific market, there is a lot of activity. When I look to, measure the market, when I do my forecasts, the two big markets overall that I see driving it are Europe and Asia Pacific, with the exception of China. So Airtel in India, they've been doing some trials with some vendors there. We're also seeing, like Jio and Vodafone are also exploring Open RAN. Some of them are even talking about, becoming their own vendor as well in that space. NTT Docomo, certainly in Japan, they announced this year, the creation of what they call the 5G multi-vendor ecosystem, what they're looking to put together is to really accelerate the adoption of Open RAN specifically towards 5G. And Docomo has been a member of Open RAN or ORAN for several years as well. And then some other ones we're seeing that don't get quite as much coverage, like we're seeing things in Malaysia looking to deploy with LTE. Several, Indonesian operators, are already started doing some small scale deployments themselves. And on top of that, TIP itself opened up even a laboratory where you see all the operators coming there working with the different types of solutions to help kind of seed the market and get them exposure to everything involved with Open RAN and how to run those networks and their performance. So overall, just a couple observations in looking, like I say, over the last 12 months. How have things changed? One, I've seen the size of trials continue to get bigger and bigger. When I first started looking at this, outside of Rakuten, 6-site, 12-site type trials were not unusual. And then during the course of the year, I started hearing more and more about like 100-site trials. And now you see, like I said, with Vodafone, they're talking about 1,000-site trials. So you're seeing operators kind of take steps towards building larger and larger scale networks as they become more comfortable with the architecture, the interfaces, and the vendors that are supplying it. Though I will say a lot of the deployments still tend to be somewhat more in the rural areas or in areas where the network is somewhat isolated from the main, such as an indoor network. You're seeing a lot more LTE out there, and even 2G and 3G in some markets, again, such as Africa, Peru is another one. But I'm starting to see more going on with 5G, particularly, say, in some of the lower bands, not as much in millimeter wave, but with the exception of Rakuten. And then also starting to see kind of a shift in the procurement as well, which is another sign of the maturing of this market. If you were to go back, say, even 2 years or so, that with these trials, a lot of the operators would look towards, particularly their software suppliers, to say, all right, go out and get me the servers, go get me the radios. Now, in my discussions with the operators, you're starting to see a lot more of them, purchasing each element on their own. And another thing I've really seen, especially in the server side, where you do definitely see the operators' IT staff having definitely some influence there in terms of the servers, where if they are already working with certain vendors on servers for other needs within the organization, within the enterprise, or even delivering, say, enterprise services, looking to use them as well for their RAN. So finally, some advice to operators. If they're thinking about this, if they're looking at this, certainly, not only do you need to look at, say, the hardware and the radio, but you also have to make considerations about system integration. How are you going to operate and manage and automate the network? Secondly, thinking about, what are you doing internally, culturally, to move to that virtual cloud type environment and the requirements there? And do you have the talent already in-house, or is it going to require a level of training or hiring? And certainly also I would think about, picking your spot for deployment. Think about a reason why you might want to change from your traditional way of deploying or your traditional vendors, whether it's, again, low population, or you're looking to do something with, say, a special enterprise type service or application. Find some different things where you definitely can have measurable improvements, or definitely can measure how Open RAN has positively impacted the network. So with that, let me turn it over to our first speaker, Ravi from Altiostar, who is the Senior Product Manager there, who'll be talking about partnering with disruptors in the Open RAN space. Ravi?
Hey, thank you, Daryl. Hello, everyone. This is Ravi Bhatt from Altiostar. To give you a quick background on Altiostar, Altiostar was founded in 2011 and has been the front runner and disruptor in the virtualized cloud RAN space. Altiostar was the first to deploy the 4G and 5G vRAN application in a commercial operator on a purely COTS-based hardware. Right. Today, I'll be presenting and discussing on how we are enabling the change in the mobile network landscape with the support of various partners to meet operators' deployment requirements. Right? All right. So why Open vRAN networks, and what's driving the operators towards it? Right. To sum it up broadly, the key drivers, the first thing that comes to mind is the no vendor lock-in. And that is to say, mobile operators have the flexibility to replace an incumbent vRAN solution provider with a vRAN solution from another vendor. And this is where innovations around disaggregation, standardization of interfaces, play a key role. And that's how mobile operators gain this flexibility. This also has kind of contributed to the evolution of a broader vendor ecosystem, where new vendors can enter to the RAN solution space, and hence creating more competition, right? So the more the competition is, the better for operators, allowing them to realize a lower TCO cost, if you will, right? And we're already witnessing this. Mobile operators are engaging with multiple vendors, pushing towards generic, open, off-the-shelf hardware and contributing to the open source software as well. Right. And the second big driver that comes to my mind is the shift towards a software-driven network, right? And mobile operators want to have a flexibility in terms of rolling out new features, faster faster update cycles, and software-based RAN solution enables mobile network operators a higher degree of programmability and automation, right, without having to compromise necessarily on security and resiliency. So this is the whole drive is towards software and taking and leveraging and harnessing the power that software brings in terms of flexibility, right? Okay, moving on to the next slide. In an open RAN architecture, right, the RAN can be broadly decomposed into three building blocks, if you will. The first one on the left, if you see in the diagram, is the radio unit. The next is the distributed unit, which is also referred to as the DU, and the centralized unit, which is the CU. The RU, or the radio unit, is where the radio frequency signals are transmitted and received. The RU is also typically located or integrated with the antenna. The DU and the CU are the computational parts, right? And these together provide the functionality of a traditional legacy base station, and it sends the digitalized radio signals into the network, right? So the DU is again due to the fronthaul latency requirements. Typically, DU is located near to the RU, and the CU can be, hosted on the central data center or near to the core. So with disaggregation, the traditional base station implementation is to some extent decoupled. You have hardware and software components, and this provides operators the flexibility to choose appropriate hardware and software solutions to meet their deployment and capacity requirements, right? And Altiostar, as a vRAN application provider, collaborates and validates its solution prior to deployment, to reduce risk of interoperability, which is inherent when we think of a network with components or network elements from multiple vendors, right? So as of today, we have collaborated with multiple cloud platforms like Red Hat, VMware, Robin, and so on. We have also validated our vRAN application on variety of makes and models of hardware platforms, like players like Dell, Contron, Supermicro, and so on. And it's very important and essential that we also interop our VDUs with the RU vendors in the ecosystem. And interestingly, there was one instance where a proprietary RU, which was already deployed, was repurposed to support the Open RAN fronthaul interface specification, enabling it to interoperate with Altiostar's DO. Right, so we are already seeing this transition from proprietary to a more of an open and generic infrastructure on all fronts within an operator's network. Now, since Open vRAN is in its early days, if you will, most of the operators, they need confidence. They need confidence in that the products that they are deploying are going to interoperate, and that's where Altiostar is taking a lead towards collaborating with various vendors across the RAN space, right? And as you see in the slide, we have listed 5 vendor types that we collaborate on a day-to-day basis for multiple vendors and multiple customers. And this list is likely to grow in the near future, right? With the introduction of innovation or innovative solutions like the RAN Intelligent Controller RICs or RAPs, right? While our collaborative efforts continue, the success of Open RAN in the long run, it hinges on the operators and system integrators' abilities to develop and they execute a thorough integration and test infrastructure in their facilities. And there are a lot of initiatives such as OTIC and so on, which which would ensure a common platform to certify these devices from various vendors, which can build further more confidence in accepting and embracing these technologies. So let's discuss on how Altiostar's vRAN solution can enable an open vRAN deployment, right? First and foremost, Altiostar closely follows ORAN and standard bodies and ensures our vRAN application adheres to interfaces and specifications defined by these bodies. And these includes, the various splits on the defined for the front haul and the mid haul interfaces, the standardization and a generic management plane interface, and interface, of course, towards the core network elements, which is typically defined by the 3GPP. Altiostar vRAN applications are designed and are based on the cloud native and microservices principles. So enabling our vRAN application to support different scale of deployments and giving the flexibility to scale out and scale in to meet the varying capacity requirements. Secondly, to enable end-to-end automation, Altiostar's vRAN application supports zero-touch provisioning. Say, once a cell site is powered on, procedures such as call home, certificate enrollment, and overall auto-commissioning gets executed, and we have already demonstrated this in multiple deployments, commercial deployments. We are also witnessing a lot of innovation in the network automation, slice management, and orchestration aspects of a network operation. And Altiostar is already geared towards it. Our applications can be directly integrated with these external third-party configuration management, fault management, and performance management systems without necessarily having our EMS as an intermediary, allowing a direct communication and having multiple consumers of this information to proactively act on any of the faults or enable auto healing related functions. So here, this is a very high level open vRAN deployment model that we wanted to discuss in today's webinar. This is something that is being considered for a tier 1 operator, where we are collaborating with Red Hat and IBM. As it is as is the case with many operators, this operator has a dense and heterogeneous deployment model, which includes both macro and small cell sites. In this network, the Altiostar VDU will be hosted on the edge data center for urban areas and on far edge for rural areas. The Altiostar VCU will be hosted in the central data center and will be responsible for managing both macro and small cells. Right. So, in this for this particular case, operators deployment case, Red Hat will be leveraging their OpenShift container platform as the as a cloud platform. Will be offering that as a cloud platform, and will be responsible for the instantiation of the vRAN applications across different aggregation points, right? So it will be responsible for instantiating the CU and the EMS on the central cloud. It will also be managing and monitoring the edge clouds, where it will be instantiating the DU on those edge clouds for urban areas. And the key, the Red Hat's OCP platform is key when it comes to instantiating the VDU on the far edge, where the VDU would be instantiated on a remote single server, right? So we are seeing a lot of we're seeing a lot of traction, and we're seeing a lot of TCO benefits which operators envision with this kind of a deployment, which is the DU at the far edge. IBM's TNCM solution, plays a key role in delivering the infrastructure management, orchestration, automation, and assurance of the vRAN workloads. And we will see how these are enabled in the following slides and rest of the presentation today. With that, I would like to wrap up. Thank you. And over to Michael from Red Hat.
Thank you, Ravi. So I'm Michael Tadeau, Chief Technologist Telco for Red Hat. So I'm going to touch to another part of the, let's say, the overall solution, which is the cloud platform. So as Daryl has mentioned at the beginning, one of the major triggers to consider Open RAN for a telco service provider is to move to a cloud mindset, in fact to a telco cloud. And so what I'm going to explain is around this open telco cloud platform at the edge, and not just at the edge, that we think is very important for the success of Open RAN, but also for the success of telco service providers in general. So if you step back a little bit, what you see now is that most, let's say, in the network, all the workloads now they're running on Linux. Okay, most of them now have been virtualized with a movement called NFV that started, in 2012. And a lot of them now are even further optimized because everybody is now using the Linux kernel as the underlying operating system, and most of them are also now being containerized. Okay, this has happened much earlier on the IT side, but now there is really the opportunity for telco service providers to implement a horizontal telco cloud across their entire footprint. So they have started to do this, on this diagram, you see the right-hand side of, it's obviously in IT. This has started with virtualization a long time ago. In 2012, it started, and this is now in big deployments. This has been applied to what is called, the mobile core, which is kind of in the middle of this picture. And what we are talking about today, is what Daryl has called the open vRAN, is to extend, the virtualization and now the containerization to the radio access network. And so why do that? Well, to become more efficient and to reap the benefits of cloud computing. So what is cloud computing? Cloud computing is to have one pool of common IT resources and use it for as many workloads as possible. So it has been done for IT. It has been done for the mobile core. Now let's extend and even increase the ROI of such a telco cloud platform by applying it to the let's say near edge and far edge of the network to host open vRAN solutions. Okay, so the underlying principle here is that you become more efficient by having a standard operating environment, for your IT core network and now mobile radio access network workloads. And while, let's say, we are going to focus here a lot on the lower, red layer in the stack, which is a common telco cloud stack, there are also other layers which are important, which are kind of higher level in the application, the IT stack, which is a common automation stack, with, for example, a common language across, automation language across the entire footprint of a telco service provider, like Ansible. And then also, when you're talking about the RAN and the edge, a common middleware stack for, running applications at the edge, in the core, and in the IT. Okay. So at Red Hat, we clearly believe that telco service provider, to become more efficient, to introduce, innovation faster, they should, as much as possible, standardize on these different stacks at different layers, So today we are going to focus mostly on the common telco cloud stack. And so the next slide is going to give some of the important technical requirements that are needed to support these new Open RAN vRAN workloads. Okay, so obviously there are radio features that need to be implemented, and this is done by disrupting companies like Altiostar, who explain them with the different splits, different frequencies supported. And then more from the, let's say, underlying telco cloud platform. The other important requirements are like number 2, a very small footprint, a low power consumption. That's very important. In the radio access network, every piece of hardware counts, every server, and I would say even every CPU core counts, because, we are talking about hundreds, thousands, and sometimes hundreds of thousands of sites. So these things matter. The other key element for a successful Open RAN deployment, is automation, in fact, a very aggressive automation, so that, from once you have finished the, let's say, the hardware and the cabling, the electrical setup of a site, everything else should be entirely automated. So this was touched already by Ravi when it comes to the, let's say, the deployment and the configuration of, for example, Altiostar's, vRAN workloads. But at the platform level, where we, Red Hat, we are acting, it means also automatic installation and configuration of the switches. It means automatic, updates of the firmware of the server, and then installation of the operating system, and then followed by the installation of the cloud platform itself. And this is not, not just the initial installation, but also the day 2 operations. They need to be, automated aggressively as much as possible to minimize, sending people on site. What also has been highlighted by a little bit by Ravi is that here we are dealing with especially at the DU side, so which is at the far edge, which is closest to the antenna and to the radio unit. When you're talking about the computing workloads, we are dealing with processing radio frequencies at a very high speed, and this is in fact a lot of data. We are talking about really huge amounts of data. This is the raw, let's say, radio frequency signals that need to be processed by the server. So this requires 2 things. First of all, dedicated hardware acceleration. A general purpose CPU alone cannot do it, which means the cloud platform has to support things like, for example, Intel FPGAs, and in the future also, other types of GPUs. And also, because this is, again, we are talking here about something that is real time. We're talking about the radio signal. It means that the operating system needs to give deterministic, processing time to the radio workloads, especially, the distributed unit, which means that the operating system needs to give ultra low latency in the range of, microseconds, and in a predictable way. And this is, a core competency that can be, given by a real-time Linux kernel, but which is not easy to implement and not easy to support. And so something that's one of the things that we are focused, and we have, finely tuned with all the vendors at Red Hat. Last but not least, there is security. Here we are not operating, if we are at the far edge, we are not operating in a data center. Physical security is lower, and you must, assume that somebody, can get access to the hardware, to the disk. So it's important that if this happens, there is no security breach, there is no, confidential or personal information that, somebody can take. And you must assume a non-trusted environment. So there are a number of features here also that need to be delivered out the cloud platform level to make this possible. So these are really the requirements that are really specific to the radio access network workloads. But one should not forget that, in fact, at the edge, we are, if you want to monetize 5G, you're not going to just deploy, let's say, Open vRAN workloads, which is just, providing radio access. Okay, maybe at the, lower latency, with higher bandwidth. But really, to monetize, the investment of 5G, it becomes clear that, new types of services needs to be offered, especially to vertical industries in the B2B space, And in fact, this requires, that at the edge, you deploy things like multi-access edge computing, and also in general, edge computing services. And this is one of the areas, of let's say, business exploration and experimentation now that all telco service providers, around the world are involved in. They are looking to to offer, to enterprises, these edge locations, especially for the local processing of data, the local, let's say, running local machine learning models. And then to enable enterprises to do new things that were not possible now, and to reap some commercial benefits out of that. Which means that in fact, so what does it mean for the telco cloud platform? It means that it has to satisfy the requirements of the radio access network workloads, so 1 to 5, but as well, it needs to be very attractive as a general purpose computing platform to develop this kind of new, edge computing services that are yet to really to be invented. Okay, so that's something very important that we also would like to highlight. So how does it look like? Very briefly from a deployment point of view. So Ravi explained, what are RU, DU, CU, and here, in fact, what you can see on these three different lines on top are different deployment models and how these network functions can be, differently distributed across the network. With, let's say, on the left hand of the slide, what is called more the far edge, in the middle, the near edge, and then the regional, data center on the right hand side. So on the top, you have a classical, very distributed deployment where kind of everything is all the computing is at the far edge. So this is a traditional deployment. That's the only one possible, if you don't have a lot of, a lot of fiber for your mid-haul on front-haul. And the other extreme, and I would say from a computing point of view, most optimized deployment is when you put, when you try to centralize as much as possible. So it means DUs, CUs are all at the near edge, and you have maximal centralization, which means that you need overall a lower amount of computing resources because they're centralized and shared across a larger number of cell sites. Okay. But again, this depends on the, let's say, the bandwidth, the type of connectivity that's available, and in the middle, you have a kind of, deployment type in the middle. So again, what we would like to highlight here is that when these workloads, are all, let's say, deployed on a common telco cloud platform, whether it's for the far edge, the near edge, the regional data center, it makes it much easier to move these workloads, and as you deploy and maybe you get more fiber, you can go more towards a centralized approach. You can move these workloads as you are, because they have been tested on this, on this telco cloud platform, and you can adopt your network more easily than with the traditional appliance-based network. Of course, the second benefit, highlighted also by Ravi, it puts a lot more pressure on your vendors because, the underlying hardware and cloud platform, is being a constant, while the workloads themselves, can be much more easily replaced. Okay, and just to explain, some of the names here in the Red Hat portfolio, what we're using for the telco cloud platform is OpenStack, which is more for the virtualized ones, the first commercial deployments on 4G, and then going forward now, as these workloads are all becoming containerized, we have another product called the OpenShift container platform, which supports containerized workloads. And lastly, what I would like to highlight is some of the, and Daryl in fact alluded some of them. So we have been, let's say, with this telco cloud platform, we have been on the, on a large scale. Let's say we are now in production on a large scale in the network of Rakuten Mobile. I think Daryl, he shared some of the numbers. I think more than 5,000 sites already deployed by 2020. And I would say, while we started, with 4G and OpenStack, our Red Hat, real-time enterprise Linux is also hosting, 5G workloads going forward. So this is, it's a proof point. It works. Okay, yes, it's a greenfield operator, and things might be different for a brownfield, but the proof point is there for the technology. The other thing I would like to highlight. this is a new technology, okay? So there are some, maturity issues. And of course, we want, and this was also highlighted by Ravi from Altiostar, we want to make it easier, to deploy this, for telco service provider to deploy this technology. So we are also working, with a lot of different vendors in the ecosystem to pre-integrate and to test, all of these workloads. And hence the prime importance of having, a very extensive ecosystem of partners, to minimize the risk, of deploying this type of technologies, to speed up, the integration. And also, last but not least, I would like to highlight, this is not just for the RAN, this is also for edge computing. It needs also to be a very, and you need also to be able to attract developers, the people who are going to make these new services, these new 5G services that are going to enable telco service providers, to get an ROI of this massive 5G investment. Okay, so here just a number of facts about Red Hat's, telco cloud platform. OpenStack, has been, it's been very successful, has been deployed, across, hundreds of service providers, and right now it's in production, for major workloads like the EPC and IMS, which is voice over IP, for hundreds of millions of mobile subscribers. And as I said, in the previous slide, we are the platform is hosting Open RAN at scale, at Rakuten Mobile. And now the next wave is, in fact, the containerization, because the containers are even more efficient, and all these telco workloads are getting containerized one by one. And here you get a number of, let's say, CNF vendors that have already publicly, endorsed the use, of the OpenShift container platform. So you will find a number of press releases. Below you have a link to the, let's say, our CNF ecosystem catalog with some of these, public statements. And our container platform has also been chosen already by large tier 1 telcos, in the North America as well as in Asia for their 5G core network. So the message here is the container platforms for telco networks are getting into production. And it's also going to happen very quickly for Open RAN. And the last thing I would like to highlight is that the attractiveness of the platform is also very important for general purpose computing. And let's say the Red Hat OpenShift container platform has already, more than 2,600, customers. You can, when you deploy on it, you can deploy on the edge, obviously, that's for Open RAN, for edge computing, but you can also deploy, on premises, in the VMware IT cloud or in any of the major public clouds. And that's also important, when you make an end-to-end application that has some part at the edge, but also some parts, on premises or in a public cloud. It's also very important to have, a very extensive, developer tooling to make it easier for them to develop on top of this platform, and also to bring middleware components, like messaging queues, Kafka, real-time analytics, a number of databases that can be used, to ease the deployment of these new solutions. And, the most important workload at the edge, we think is going to be AI/ML, and it means, that the platform needs also to have very good support for that. Okay. So that's it. That's it. And I'm done with my part. And I think over to you, Sanil.
Thank you. Hi everyone. I'm Sanil here, and I'm the CTO for the Telco Network Cloud business in IBM Asia Pacific. And I really want to thank Daryl, Michael, and Ravi for setting up the context so nicely for me. So that I can bring things together in this last section, talking about automation in the context of Open RAN and in general. And before I do that, I want to preface this discussion first before really getting into my first slide. Look, the cost of managing and operating this new Open RAN network and the legacy network, which is not going away, will have a big say on the long and short-term profitability for telecom operators. And this is due to the legacy cloud and radio sprawl that is already there, the network cloud disaggregation that Michael was talking about, the decentralization of data to hundreds of edges, and of course the radio disaggregation, which Ravi talked about, from an Open RAN point of view. So while all these disruptions in the industry is great for innovation, it also indicates a lot of operational complexities, which can inhibit the value these innovations bring. And hence, we need to look at TCO carefully and how to manage it. So hyper-automation is the only solution to this complex problem of TCO. And with that, preface, let's see, what problems are we trying to solve using an all-pervasive view and not really taking a middle ground on automation. So in IBM, we have, something, called as the automation factory. And the key goals of this automation factory is to provide automation packaged content in a single pane of automation software with, bringing our ecosystem of partners and bringing a repository of automations for day 0, 1, and 2 operations for any kind of service, which will be fully certified on the, the OpenStack or the OpenShift platform, and also with our IBM automation solutions, so that we completely de-risk for our partners and for our clients, while deploying these solutions to bring down that TCO. So there is a large ecosystem which Michael talked about. There is a large IBM ecosystem. We are bringing all of those things together. And also we are farming the project automations that our services partners are also doing within our telecom customers to bring all of those, learnings back into this automation factory. So, it's something that we are building over the last year or so, and it's a rich packages of content that we are bringing to the table with our automation solutions, which is very important to attack this whole notion of automation in a really all-pervasive way. Right. So, apologies if the screenshots are a bit blurred, something to do with the compression in the PPT, really out of my control, but you will get the slides in PDF with high quality images. Okay, so while application of automation is mostly discussed in the context of OpEx or TCO discussions like we are doing now, our work with large operators in Asia Pacific have led to the realization that automation cannot be taken with a myopic, short-sighted view. And so we framed automation in the context of the business processes of the telco, like the plan to design to order, the design to build, the build to manage of any service. So in this example here, the automation, is really all-pervasive in the sense that it is not really looking at the fag end of the automation where, VNF onboarding happens. There is a whole lot of other things that the telco needs to do to bring down the OpEx curve while rolling out these disruptive solutions. So it could be in the form of a catalog-driven cloud planning or radio planning approach. The shape of the cloud is really dependent on by the VNF resources or the CNF resources. So how does a planner in an engineering or a planning team of a telco take a catalog-driven public cloud-like experience and plan the cloud for a deployment? How do we generate the bill of quantity required for rolling out hundreds of sites? How do we create the low-level design of the cloud, for example, for rolling out these clouds in an infrastructure as code manner? So the point I'm trying to make is that we have now in our solutions, in our automation solutions, looking at not only onboarding, which is at the fag end of the journey, but right from plan to design, how do we completely automate all of these things? Dynamic VM placements, dynamic compute placements, all of those aspects as well are very important. And we can call the right AI ML models where placement algorithms are placed to make sure that we can bring all of those automations together in one cohesive flow. Once the low-level design for the cloud is deployed or is generated via the automation, we really build a JSON representation of that template, of that low-level design, and then feed it to whichever is the cloud OS, so whether it's OpenStack or OpenShift, and we actually build the NFVI layer, which is the compute layer, the cloud OS layer, and then we do rigorous tests on the cloud OS itself automatically using the behavior test platform, and then hand it over for VNF onboarding or for XNF onboarding or CNF onboarding to make the end-to-end service up. And I'll talk about zero-touch provisioning in that context later. And then once the day 0 and day 1 are done, we hand it over to network operations, where the same solutions can handle the day two operations of the cloud, as well as the radio network, as well as the core networks. So this sense of overall automation, is the only way forward for lowering the TCO because of the disaggregation and the complexities that the disaggregation gets to the table for telco. So that's really what our mission has been, an end-to-end lifecycle management with hyper-automation, all the way from plan, design to order, order to build, and build to manage. This is another really a representation of what I just talked about. Once we do the cloud planning, we populate the low-level design of the cloud, which is required by the Open RAN network, into some sort of a JSON template, which populates what we call as the data center information model or the site planner within our automation solution. This site planner has a model of OpenStack. It has a model of the RAN itself, whether it is an open, ORAN 4G, it's a FlexRAN 4G, or an ORAN 5G or 4G. We have models which are overlaid on the cloud itself, so that a planned inventory of the site is available automatically with a single click when the cloud planner or the radio planner is actually, planning that particular site. Once that is done, a single click from the site planner will convert the planned inventory into a set of declarative templates within our intent-based automation solution, which is called as the Cloud Pak for Network Automation, which Ravi referred to as Telco Network Cloud Manager, or TNCM. And the service model for the entire data center site and the radio site is then laid out in this particular declarative model. And then using the right southbound interfaces, the NFVI is set up, the bare metal introspections are done, the OpenShift or the OpenStack is set up, and the workloads are onboarded seamlessly. So depending on what kind of site you're designing, any shape or form of the site can be deployed using this closed loop automation that we have put together to really cookie cut the build of the sites to make it completely consistent and error-free and with zero defects and zero complaints. The goal is that the technology should not really be the reason for you to have any sort of defects in your automation. Okay, so that's really what we want to do with a declarative way of doing things in the network, an intent-based automation that we are bringing to the table. Some example screenshots of how the cloud planner looks like. It's really single click. It's really catalog driven. Because of the standardization that the telecom operators are now bringing to the disaggregated stack, it gives a huge impetus to automation. There's a huge opportunity for automation because of the standardization that the clouds are getting into and the full stack is getting into, and hence we are able to provide this really opinionated way of cloud planning or radio planning to the site planner, bring the cloud configurations into the site planner, and then push it into the declarative intent-based automation, which will then deploy the day zero, day one, and then take over the management of all the day two operations of this infrastructure and the network services that we have put together. This is another view of the CI/CD platform, which is part of the automation solutions of how changes can be rapidly done, with the partner solutions that we are bringing to the table, and then putting it into a test platform, a dev platform, doing proper pre-production testing, and then seamlessly putting it into production using the automation solutions as well. Finally, when it comes to day two, we also want to represent what we just deployed on the cloud so that the operations team have full observability and visibility of the service that was just deployed, all the way from the fabric to the cloud, to the hardware, to the cloud, and to the applications that are running on it, and the really the VNF forwarding graph or the network service as a whole represented in a nice dynamic topology. The dynamic topology that you're seeing here is literally an Altustar deployment of the VCU. It's actually a small cell deployment. So you have the DHCP servers, the DNS, the security gateway servers, as well as the VCU and the DUs there, deployed on OpenStack all the way, onto the network interfaces that the NICs expose, etc. The point we are trying to make here is that there is a real-time view of what the automation solution is doing immediately. You can always go back in time and see what happened 1 hour back, and what exactly did the automation solutions do? Was it according to the right compliance and the right policies that our customers needed? So it's almost like a governance tool what the automation solution is doing. So explainability and governance of what the automation is doing is actually available in day 2 operations within our solution itself. Of course, we have fully integrated ourselves with the Altiostar set of solutions and all other Open RAN solutions. We have also gone ahead and integrated the performance as well as the fault management aspects coming from the Altiostar EMS, so that we can do things like alarm correlation, overlay the alarms on top of the topology to do impact analysis and blast radius of the impacts, etc. Very, very easily using all the AI and ML infused operation solutions, which are part of our full stack of automations. Finally, I want to end with this high-level view of the zero-touch provisioning. It's a very simplified and an abstracted view. But that does not take away the fact that behind the scenes, there has been significant engineering work to make this happen by, IBM working with our partners like Altiostar and Red Hat, leveraging 3GPP and EDC standards to enable, the level of extreme automation when making an Open RAN site ready for service. From metal to ready for service, including setup of the NFVI, setup of the cloud OS, stack or shift, doesn't matter, onboarding of the XNFs, the day 0, day 1 site configurations, the radio configurations via IRP interfaces, the configurations that needs to go into the VCUs and VDUs, via NetConf, all of those, and of course the day 2 service assurance setups, like I just showed you, the dynamic topology, the alarm correlations, and the radio parameters, metric anomaly detections that are all part of the solution. So right from the defining the blueprints, generating the cloud planning and the overlaying the radio parameters on the cloud and onto the ORAN models that are available within our solution, interacting with the cloud platform, interacting with the manual work that needs to be done with the field services, which could be a partner or the telco themselves, and bringing that zero-touch provisioning whenever a radio site is switched on all the way to ready for service is really represented at a very abstracted level here. That's really the way. That's probably the only way in making the service profitable, because of the because we have to flatten that operations curve, which is arising due to the disaggregation of the network that we spoke about, and really the only way to make the service profitable is really to flatten that curve with extreme automation. And that's really a wrap from my side. Do please reach out to the speakers with the context given in the slides for further offline discussions, and thank you for listening.
Thank you, Sunil and Ravi and Michael. Certainly some great information there. I mean, two of the things I think about right away is one, obviously some great illustrations in terms of the variety or the different types of network architectures that are available with Open RAN. And two, I think it was a really good way of putting into context what we've talked about earlier in terms of moving into a cloud environment and really and how that relates to the RAN environment. And a few other thoughts I just want to leave the audience with. Certainly, Open RAN is still a new architectural type in the mobile infrastructure, but it is a commercial reality and it's taking place right now. It is global. It is very much, in my opinion, still an operated, driven change in the paradigm of the vendor-operator relationship when it comes to the RAN. And certainly, beyond just thinking about the radio and the baseband unit and all that, I certainly think, operators as they move this really also have to really think a lot about the integration, the automation, and, again, that entire cloud environment and how they're going to manage that as it applies to the radio access network. And with that, this brings our webinar today to a conclusion. And as we said earlier, this is where you can reach out and contact the different speakers if you have some questions or follow-up. Thank you for joining us today.